Hi, welcome to Shiko Statistic Lecturing Series. And we are going to start a new topic today. That's very excited. And this new topic we're going to talk about is expected value. And so the expected value, then later in later videos, we're going to talk about the moments and different type of the expected value. And so for example, how do we find the variances and the losses here, okay? And so for the first ones here, we're going to talk about the expected value. How do we define the expected value for the discrete versus continuous random variable? And how about if you have a function of the random variables? And then the last things in this video we're going to talk about is how do I find the function if you have several random variables here. Okay, so let's go ahead. Before we even take a look at the definitions and the different type of the problems here. So let's go ahead and take a look at what is the expected value. I want to give you some kind of examples, and so you will see, oh, that's what that means. So like I said, most of the statistic topics are very intuitive, like it's kind of like you'll be able to apply in the real life. Okay, so for these ones here, so let's assume, okay, so you want to have a party this weekend, and then you want to invite some friends to your parties, right? So the first group of the friends, you say, hey, I'm going to invite the first group of the friends. Those are my schoolmates. The friends, we have not seen each other for a while. I like to invite them come to my parties. Okay, so you say, okay, I'm going to invite 10 people. This is my school friends here, right? I'm going to invite 10 people, my school friends. And then the second group of the people, you say, hey, I'm going to, so you said, okay, so I'm going to invite the friends I met, during my work. Okay, so I have a lot of friends during my work. And then you said, okay, I'm going to invite the 15 of them. Okay, and then, the last group of the friends, you say, okay, I have my school friend and my work. And then you will say, okay, I'm going to invite some of my relatives, like my cousin and, my nephew, and they are in the neighborhood. So maybe I will invite them over. So I have like 6 of them I like to invite. Now in here you say, okay, so if I invite them, if they all show up, right? If they all show up, how many I have? I have a total. How many? I'm going to have a total 31 people come to my party, right? So, but then you say, they are not all going to show up, right? So for example, my school friends here. So you say, hey, the school friends here, because the school just start, and then probably only have, the 1/2 or 50% of them going to show up. So you say, okay, maybe the 50% of them going to show up, and then you say, okay, 50% of them. Then for the people you work, because due to the schedule, then you say, okay, I don't know, maybe just the 1/3, or, about like 33% of the people they're going to show up because they have different working schedules. Then my relatives here, then you say, my relatives here, they are all around, but sometimes they don't like to meet my other friend. Maybe, we have a 50%, half of them going to show up here, right? So for each group, you have a different chance to show up. So now you will say, okay, now I'm going to prepare some food and some drink for my parties. Okay, so the most conservative way I can prepare the 31, right? So I can prepare the 31, like the amount for the 31 people, the amount I can prepare is for the 31 people. But well, if not all of them are going to show up, I might waste the food and the drink. So that's why I say, okay, so my school friend, only half of them going to show up. So how many I expect them going to show up? So I'm only going to expect them 5 of them, right? Then, for example, my work friend, I invited 15, and I know only 1/3 of them to show up. So how many I expect? I expect the 5 of them to show up, right? Okay, so now, for my relatives, I have 6 of them. Now I also only expect how many to show up? Half of them going to show up. So this is what? It's 3, right? So now, what do you do here? Then you say, okay, so you add them. So total, how many you expect? You expect 13 of them to show up. So see here, that's what we say. I expect 13 of them to show up. Even I invited 31 of them. So how did you get 13 here? Hey, that's what exactly is the definition of the expected value. You use your value times the probability. You use your value times your probability. You use your value times your probability. Then you add them up. Correct? All right. So that's what you expect to show up here. So the total is like the 13 you expect to show up. Okay, so now, like right now we talk about here, we say, hey, how about the weekend comes, then the actually show up person, this is 6, and this is 7, and this is 4 here, right? So this is the actually show up, right? So then I have 17 to show up here, right? So actually I have 17 people to show up. So this number, we can say that this is what we call, we call it is expected value, right? So of course, like later we have a more, like the more solid definition, but you can see the expected values, right? Is you just use the number times the probability, then you add them up. It's kind of intuitively true, correct? Then the actually show up is 17 here. So the differences here is what? The differences is 4, right? So maybe like next weekend you do the same thing, then they actually show up is only maybe 10 of them because maybe it's close to the final exams or something, right? So the differences here, this is what we call the variances, right? So we call this the variances. That means you expect 13 that actually show up is 17, right? So how big is this variation? That is another expected, how do we, find the expected value? So really this is the expected value of what? X minus, like we said, the expected value of X, right? So, and then you find it. But let's right now, don't worry about this. We're going to talk about that later, but let's just don't worry about the mathematics part here. Let's just understand the concept, right? So the expected value intuitively is true. So you have a certain number, and then for the probability for this number show up is a certain probability. So what you expect, intuitively, you use that number times the probability, right? So if you have several groups, you just add them together. Correct? It's a very, very simple concept. And then what do you expect and what is actually will happen? So this is the variation around what you expected value. That's what we call it the variances here. We're going to talk about it in the later videos here, but first understand the expected values. All right, so it's pretty straightforward, right? Okay, so now let's take a look at the definitions, right? So the definition, so it's just like we said, if f of x is the, is the value of the probabilities, right? And then the value of x is the value. So just like, so this is what we call it the expected value of f of x, the random variable x. So it's x times the probability, then you add them together, right? And of course in here, this is just I try to do the demonstration. But if you do the random variable, then all the probability you add up here should be 1. And so because random variable is covered the whole sample space, as you see it here, does not add up to 1. It's because I just try to demonstrate the concept about expected value. All right. So that is what we call is the Let what is we call it is the expected values, right? Okay, so now, let's take a look here. The next one's here, right? So the next one is, like I said, if it's a continuous. Okay, so if it is a continuous, remember the only differences between continuous and the discrete is instead of the summations, right? You summation all the x values. What do? You do the integration, right? So we did this in several several problems, several videos before, several different topics. Like we talk about the distribution functions, CDF. For the CDF, if it's discrete, you use summation. If it's continuous, you take the integration all the way to x, right? So it's the same idea. So now the expected values here. Okay, so it's you use your random variable numbers times the associated probability, then add them together. If your random variable is continuous, then you still use you use random variable times f of x. Then you integrate it instead of summarize it because they don't have each individual numbers here. Okay, all right, so let's take a look here, right? So let's take a look, let's say a lot of 12 televisions here, right? So then I have two of them is with a white cord, all right? Then I'm going to, 3 of the set are randomly choose from the randomly shipment to a hotel. So how many set we're going to expect, right? Right, so how many set of white cord we're going to expect to the hotels here? Okay, so now let's take a look at how do we do these problems here. So I have 2, right? I have 2 white cord here. So remember, if you want to find the expected value, you need to have the value of your random variable. Then you need to have the probability associated with that, all right? So because they have 2 white cord, you randomly choose 3. So what are the possible numbers of the white cord here? So this is 0, right? So you can have a 0 white cord. You have 1 white cord. You have 2 white cord, correct? Okay, and now we need to find the probabilities, right? So let's see here. The f of x equal to 0. So what is the probability I'm going to get 0 white cord? That means in here, okay, so total, how many sets you're going to take? You have a 12. You can take 3, correct? Right, so you have a 12 sets, you take 3. Because you have 0 white cord, and I know I have 2 white cord, so it's 2. Then you take 0. Okay, so what happened to the different colors of cord? You have how many? You have 10, right? So 10, so how many you have here? You need to take 3s, right? Right, because all the 3 sets you take not the white cord, so it's 10 of 3. So if you plug this into your calculator, you will get this is 6/11, right? So this is the combinations, right? Okay, so now let's take a look at f of x equal to, here, let's take a look here. This will be f of x equal to 1. Okay, so here, let's write it. This is 6/11. Okay, so f of x equal to 1. So let's try to one more time to see we know how to find the probability. So total how many? 12, right? You take 3 sets. Now I'm going to have 1 white cord. So that means out of the 2 white cord, how many you take? You take 1. Good. Okay, so how many is non-white cord? It's 10. You already take 1 for the white cord. So how many is non-white cord? Has to be 2, correct? Okay, so if you put it into the calculator, and I'm not going to do the numerical calculation here, you will try to practice your calculator and get that. So this is 9/22 here. Okay, now, okay, so now let's see here, f of x equal to 2. Okay, so f of x equal to 2, so that means 2 white cord. What do I need to do? You take 12, you take 3. So out of the 2 white chord, how many you take? 2. Okay, so the remaining is the non-white chord is 10. You already got a 2 white chord. So how many is in here? Is 1s, right? Okay, so now if you put it into the calculator, it's 1/22. So this is 1/22. Like we mentioned before, one way to check it is if you add these 3 together, what do they have to be? They have to be equal to 1. Then you know you did the calculation and your distribution table is correct. Okay, so now what is the expected values here? So the expected value will be the value of your random variable times the probabilities, right? Just like with the party example we just did. So this is 0 times 6/11 plus 1 times 9/22, then plus 2 times 1/22 here. So you will get it's 1/2, right? So this will be our answers here. So then you might ask, you say, hey, how can I get 1/2, the TV? Okay, so the way you interpret the expected value, it really is meaning is kind of like, that's what I like to call it, is long-term averages here. Okay, so what I mean the long-term average, that means, for example, at this shipment, yeah, maybe you get 1 white chord, or you get 0 white chord. So the expected value, that means if you do this again, and again, so every time you deliver the 12, the TV set, and then you deliver another 12 TV set. If you do it again and again and again, so sometimes you will get a 1 white chord, sometimes you will get a 0 white chord, sometimes you get a 2 white chords, and then if you do it many, many times, then you average that, on average, it will give you 1/2. All right, so of course we cannot have a half of the TV. So this is what we call is long-term average. That means if you do it again, then you average that. So in general, it's 1/2. That means probably, the chance to get a 2 white chord is small. So probably it's kind of like a 0 and 1 running around between these 2 numbers every time when you deliver to the hotel. Good? Okay. Now let's take a look. The next one's here. All right. So the next one's here is find the expected value of the random variables here. Okay. So then I'm looking for the expected values here, right? And then this is my what? This is my PDF. So this is the continuous distribution. So this problem basically is just try to test you. It's very mechanical. They want to see, the definition about expected value. So what expected value is x times f of x dx, right? Okay, so then here, so the x here, don't forget, here is your limits, right? So this is from 0 to 1. So this is from 0 to 1. Then here, this is the 4x and the pi, 1 plus x squared dx here. And like we said here, this is not a calculus class, but here I'm going to show you a quick way. Okay, so now here will be, what I can do is first, I can move the 4 and the pi outside, right? These are the constants. So this is 0, x is 1 plus x squared dx. And then I'm going to use the u sub. And like I said, I'm not teaching the calculus, so you better, if you have trouble, you need to review. So I'm going to use u sub, right? In your calculus. So I'm going to say this is 1 plus x squared. So what is the du's here? Du will be the 2x dx here. But if you look inside here, right? So if you look inside, this is only x. So that's why you divide the 2. So you will get a du over 2 is equal to the x dx. Okay, so now this one I can simplify that to the pi 4 pi over 2. Then this 1/2, I can put outside, is 1/2. And in here, we're going to temporarily skip the limit because this limit is for x. I have u. So this will be du. The x dx is du's, right? Now here is u, right? So now I know this one's here. I cancel here, simplify a little bit. So this is a 2.5, 2 over pi. And then what is this one's here? This will be natural log u's, right? And so now for natural log u, then also we have the limits here. I'm temporary, I'm not going to put it. So this is a 2 pi. So what is the natural log u's here? The natural log u is 1 plus x squares, right? So now I can put my up and the lower bounds here, right? So in here, if you want, you can just say A and B, because you need to change the boundary. One is to the x variable, one is to the u. So you substitute here. So you will get the answers here is pi and 2, natural log 2, right? Or you can bring the 2 inside. So this is the natural log 4 here. Okay, so this is 0.4413. So like I said, this is a statistic class. I'm not trying to test you a calculus. If your teacher allowed, you can just put it into, there are so many integration, software, so you can just put it and they will solve it for you. And but if your teacher wants to go through that, so I still recommend you, try to go through the integration. Just make sure you know some very basic integrations here. Okay, so the next things here is like, how about this is the definitions here. We say, how about instead of finding the random variable, the expected value, and so how about if you find the function of that random variable? So it's the same things here. That means you just, instead of times the random variables here, you just times that function. So here you just times that functions here, right? And then for the discrete, you add, and for the continuous, you integrate here. Okay, so here, this one is a very important formula. So let's say, for the random variables here, right? If you have ax plus b, if b is a constant, then your random variable will just be, the expected value will just be, that you can take this a out, the ex, and then plus b. So just like, the example, the party examples here, we say how many people going I expect. So if I change that, I said every person is going to bring 2 extra friends, right? So that means I need to add the extra friends here, right? So that's why this is what we call this expected values here. Or, like if you have a constant, you can just, constant, you can take it out, okay? All right, so now let's take a look at number 3. So this definition is pretty simple. It's just like what we did, for the previous. Okay, so let's take a look at here. So if the x is the number of the points, y row of balanced dice, find the expected value. Okay, so now in here, first things that when we try to do this, we always need to do, this is x and this is f of x, right? So when I do a dice, so I will have 1, 2, 3, 4, 5, x, 6, right? Correct? The 6 faces. So how much is each one? This is balanced. So it's what is 1 over 6, 1 over 6, 1 over 6, 1 over 6, 1 over 6. Okay, so the expected value of gx is here. That would just be the expected value of 2x squared plus 1. So that means this is my x values here, right? So this is my function, this is my x value. That means every value I need to put into that function. So let's take a look. So for 1, so this is 2 times 1 to the square plus 1, right? Times 1 over 6, right? The value times the probability plus when x equal to 2. So what is x equal to 2 will be So the x equal to 2 will be what? Is 2 times 2 to the square plus 1, correct? And times 1 over 6. Let's try to do one more. X equal to 3 is 2 times 3 to the square plus 1 times the probabilities, right? Now you do da, 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 da. Here the last number, so it's what? It's 2 times 6 to the square plus 1 times 1 over 6. Right? Okay, so that is, that is what we call is the function of expected values, right? Okay, so the function of the expected value. So what is this one here? So if you put it into your calculator, it's 94 over 3. Right, so if you just find the expected value, right? So remember, if I'm just finding the expected value, you just use 1 times 1 over 6, 2 times 1 over 6, 3 times 1 over 6, 4 times 1 over 6, and then add them up. Right? So it doesn't matter if you have a function. That means, so if this is your functions, right? That means that your random variable, the values of your random variable, you just need to change to the function format here. Okay, so now let's take a look. The next examples here. So if so here is they want to find the expected value of gx. So this one's here is also just like try to test your understanding for the expected value. So let's see here. Let's do one more time. So this is expected value of gx. So that means expected e to the 3x over 4. Right? Remember, if I want to find the expected value, what I'm doing here, I use these functions, right? So I use this function, and then what I do, I times the f of x. So this is e the 3x over 4. I times the f of x is ex, and then the dx. And what is the limit I'm using here? Greater than 0, so it's 0 to the infinity here. Okay, so now let's take a look. So this is 0 to the infinity. So first I combine, this is 3/4x minus ex. So what is this? 1/2 be 1 over 4 x dx here. You guys remember when we first started the continuous random variable, I said a few things we need to remember. One of the formulas here, if this is e to the ax dx, do you remember what is the formula here? We say we just need to be very good at those very basic formula, right? So this will be 1 over a e to the ax plus c, right? So this depends on the here, if you have any constant, then you need to divide this constant here. Okay, so now for here, the constants here is 1/4, right? So when I try to do the integration, so what I'm having here, so I'm going to have a negative 1/4 e to the negative 1/4 x 0 to infinity, correct? Then you flip it. So this is negative 4 e to the negative 1/4 x, right, to the 0 to infinity. So when the infinity you put into here, so you got a big negative exponents. That means the denominator will be very big. So it's 0. Then you minus the negative 4. When you put a 0 there, so what do you have here? 1s, right? So that's why you expect the values here is what? Is 4s here. Okay, and that's it for the video number 1. So we're going to stop here so you can have time to just digest a little bit, and then we are going to go over the video number 2. Then we're going to be able to finish the remaining problems about the expected value. So right now, the video number 1, the definition are quite simple, right? So you just use whatever the expected value is. You use that function to times your probability distribution or times your PDF. So you either add them together for the discrete random variable, or you take the integration for the continuous random variable. All right, so it's a pretty simple concept. So make sure you understand. Then we can continue to our next videos. Here we're going to do some a little bit more I don't want to say complicated. It's just like, you know, it's a little bit tedious. Okay, that's it. Okay, so it's a nice talk to you. And I hope you guys enjoyed this video. And so I'm looking forward to talk to you in our next videos here. Okay, bye.